Hello everyone, this is going to be part one of our final review. If you have any questions, it would be good if you email me, or we can establish also a Zoom chat. So we're just going to go ahead and get to this. What is a serial monitor and what is it used for? A serial monitor is that little side window that you see on the left. You have to click on the word that says serial monitor. And what it does is we've connected some type of sensor. We're sending some type of message for us to verify. But primarily, this is going to show data from the sensors. We've coded it to send messages and mathematics and things like that, but primarily we use it to show messages. How do you send a message to the serial monitor? You are going to be using either serial.print, or you can also do serial print line, serial.print line, and that's going to be print ln. And again, this will have your data going down in rather than going across, it will be going down your screen. Feel free to pause at any time if this is going a little bit too fast as well. What a microcontroller is. The microcontroller, this is the brain of your whole outfit. It's the brain of your bot. And previously your microcontroller was a separate device, but with these newer devices that we have, the microcontroller is within the whole board. Not the breadboard, not the white breadboard, but it's in the whole motherboard. So it's within the motherboard itself. What is a sketch? A sketch is just your written code. It's your written code, and you need to have certain symbols to code your sketch, and that's going to be your curly braces. Your curly braces are going to be the commands to open and close your code. Commands to open and close. So again, you have this symbol here to open, and you have that symbol there to close. So only those things that are within your curly braces are coded. Well, how about your parentheses? What does this do? These parentheses are used to contain numerical values. So you usually have a number on the inside of there, or sometimes it could be left blank. For example, your setup and your loop. We don't want to have numerical values for those. What is the setup portion? The setup is it is in the very beginning of your code, and it only codes something one time. So you find the setup in the very beginning, and it codes for things that are used once. Codes for things used once. What's the loop function used for? This is after the setup. And this is going to be something that repeats the code over and over again. Now if you remember, let's say all these words here, this is my code, your code goes through each line, okay? And it's going to go through the setup just once, but if it's a loop, it's going to continuously go through that loop, and it's going to see if certain conditions are being met. And if they are, then it's going to code for the robot to do that type of command. So now we have the delay. The delay is how long a command is run. Okay, how long a command is run, or how long a command is held. How long a command is held. So a delay doesn't mean you stop and you pause. A delay of 1,000 means you're doing that command for that period of time. And if you remember, 1 millisecond is equal to 1, so 1 is going to be equal to 1 millisecond, which is 1,000th of a second. So if you have 1,000 of these, so if you have 1,000 milliseconds, so if 1,000 code, this is going to be equal to, of course, 1 second. What are your servos? Your servos are your motors. And these motors are going to spin, and these are going to be what the wheels are going to be attached to. So we'll attach those wheels to those servos, and then we can then command what those servos are going to be doing. What's the function of attach and detach? The attach function is when we put this in the setup, and this is going to enable the servos to move. It will enable them to spin. The detach is going to tell the servos to stop. How and why to use a counter? Well, we start by saying that my counter is going to be equal to 0. And we do this before the setup. Actually, let's see, that's going to be in the setup. We say counter, and that's going to be before the setup. And then in the setup, we will say my counter is going to be equal to 0. And then we're going to be having some if scenarios, and this is going to register. If a device registers a certain condition, it will advance the counter. So we can use these for whiskers. We can use them for the IR LEDs. We can also use them for QTIs. If the whiskers hit something a certain number of times, it will advance the counter. If the IR LEDs detect an object, it can advance the counter. If the QTIs come up to an intersection, which 1, 1, 1, 1, all black, you could then say, okay, I want to make a left-hand turn and advance the counter. So we establish the counter being equal to 0, and then we have something to sense. And when a condition is met, we advance the counter. So it's used to make decisions. That's what the counter is used for. What it means that a pin has an input and an output. So a pin can either put out voltage or can receive voltage. So let's talk about the input. We first did the output, like the LED. Actually, maybe we should do that first. The output, this sends voltage to do a command. Now I'm just going to put capital V for voltage because we're going to use that quite a bit. Sends voltage to do a command. Like we want to turn an LED on. Okay, that's one example. We want to have the IR LEDs functioning and sending out signals. But we can also have an input. And when it's set to input, this is going to receive voltage. So it's going to receive voltage, and it's going to measure it. So if the whisker setup is on your robot, the voltage goes to the ground, and the ground is going to be receiving that, or actually it's going to be going to the pin, and all the voltage will go to the pin, and a 5 volt will register that whisker as 1. Now, if the whisker hits, it creates a different circuit, which then transitions all of the voltage to go to the ground. In that case, none is going to the pin, so it would measure it as a 0. And those are the conditions for a whisker, for example. So when we're trying to power something, we need to have the on output. If we're trying to measure some type of system, like a whisker or the receiver on the IR LED, then we want to put those to input. What LEDs are? LEDs are light-emitting diodes. Light-emitting diodes. These are the small lights, either red or blue or green or yellow, whatever that you used. And how are they useful for us? Well, we first programmed to be blinking, but the main function is so that we don't have to use a serial monitor to detect information. So this indicates that the sensors are working. Indicates sensors are working. So instead of reading a message on the serial monitor, the LED lights will indicate that your system is set up and ready. What do digital write high and low commands do? Digital write high, we'll talk about high right here. This means that the LED is going to be on. High doesn't mean that the light's going to be bright. It just means it's going to be on. Low means the LED is going to be off. Doesn't mean that it's going to be dim. Okay, so the high and low commands are either an on or an off system. So it's not a light intensity. So it's not being bright or being dim. So why are subroutines used? Subroutines are going to be used when you're going to have something repeated over and over again. It helps to shorten codes. So it shortens codes when you have repeated commands. So instead of coding for 1700, 1300, over and over and over again in each particular section, you can create a subroutine for that. And you can say, forward is going to be the name of my subroutine. These are usually after the loop. But then it was also shown to me that this can also be found before your setup. We've been usually doing them after the loop. If this before the setup is incorrect, please let me know. So that's going to be it for part one. Good luck on this. And again, if you have any questions, please let me know.